Hello, we are just finishing up lesson 1 right now. We're looking at 1.3, drawing diagrams for equations. So in this activity, part of this lesson, you're taking what you've learned in 1.1 and 1.2 and you're applying it to draw tape diagrams with variables in them. Remember, a variable is a letter. It could be X or Y or Z, and those letters are representing some number. We don't know what that number is, but whatever the number is, it has to make the equation or the diagram true. So, 1.3, for each equation, draw a diagram and find the value of the unknown that makes the equation true. So we know that this first diagram is going to be representing division. So I'm going to start out by drawing my bar or my rectangle. And I know that the total is going to be equal to 18. Now, I have two values. I have 3 and I have x, and together they're going to equal 18. Go ahead and pause this video and try on your own to finish the diagram. Okay, if you try it on your own, your diagram should look something like this. That is representing that x and 3 are equal to 18. Now, I drew the x much bigger because I knew that 3 is going to be a lot smaller than whatever quantity we'll add with it to get to 18. Okay, for your second diagram, the second one is representing multiplication. So as we know, multiplication is repeated addition. I'm going to go ahead and draw my tape diagram and label it as a total of 18. Now, here's where it gets a little trickier. I don't know what y is, so I'm not gonna be able to fill out a number, but I do know that y is repeating 3 times. So I know that I can go ahead and split my diagram into 3 equal parts. And each of those parts is going to equal whatever y is. So that's what my diagram is going to equal. Now, it wants you to figure out what value makes the equation true. So if we're looking at this diagram, we need to know what y equals, what y plus y plus y. We need to figure out what y equals if y plus y plus y equals 18. What value could make it true? So there's a couple ways we could do this. You could try a number and you could plug it in and you could see if it works. So for instance, I could do, let's say 5. If I think that y is 5, I could do 5 plus 5 plus 5, and that's going to equal 15. So I know that 15 is not 18. So that is not correct. I could try another one. I could try 6, since 5 was really close, and try 6 plus 6 plus 6, and I know that 6 plus 6 equals 12, and 12 plus 6 more equals 18. So that worked. Another way I could have figured that out is I know that 18 split into 3 parts is the same thing as 18 divided by 3, and 18 divided by 3 is equal to 6. And so the value of y for number 2 is 6. Let's take a minute and go back to problem 1, or equation 1. We had drawn our diagram using two parts. We had x and we had 3, and they are equal to 18. So how could we figure out what plus 3 equals 18? Well, as you know, or you may know, addition and subtraction are inversely related. So what that means is that in order to figure out what plus 3 equals 18, you could go ahead and figure out 18 minus 3 equals blank. We're going to get into that a lot more later. Another way you could figure it out is you could guess and check. Okay, let's see. A guess could be 12. 12 plus 3 equals 15. Okay, that doesn't work. What about 13? 13 plus 3 equals 16. We're getting closer. 14 plus 3 equals 17. Almost there. 15 plus 3 equals 18. So this is the equation that gets us to 18, and so 15 must be the answer. Okay, that's about it for lesson 1. Please do all of the practice problems if you haven't already, and I will make another video for lesson 2. Great job. Bye-bye.